Hello and welcome to this video clips on linear, polynomial, power and rational function. In this video we will introduce some basic functions you may already have seen in secondary school. I summarize these functions since they are important tools that appear frequently in all kinds of applications. We will start with simple linear functions, then move on to quadratic functions and higher order polynomials, after which I will present the so-called power functions. Finally, I will show you how a rational function is defined and I will highlight some of its characteristics. Linear functions are in fact the most basic type of functions you can think of. A graph is a simple straight line, as you can see here. A linear function is summarized in the simple equation y as a function of x equals a times x plus b, where a is the slope of the line and b is the y-intercept, that is the value of y for x equal to 0. A line intersects the horizontal axis at the point x equals minus b divided by a. In this animation you can see what the influence is of changing a and b. Changing b causes the line to shift upwards or downwards, while changing the number of a influences the slope of the line. Note that if the slope a equals 0, then we have a horizontal line. Linear functions can be viewed as a special case of so-called polynomial functions in the variable x. The general structure of a polynomial of degree n in the variable x is as follows. Y of x equals a0 plus a1 times x plus a2 times x squared plus until an times x to the power n. You can see that a linear function is just a polynomial of degree 1 with two coefficients a0 and a1, which are again the y-intercept and the slope of the line. A frequently used polynomial is the quadratic or second degree polynomial. Y of x equals a0 plus a1 times x plus a2 times x squared. Its shape is a parabola. If the constant a2 is positive, then the parabola opens upwards, whereas if the constant a2 is negative, the parabola opens downwards. An interesting application of a parabolic function is the mathematical description of the trajectory of a moving projectile. The horizontal velocity of the bullet is constant, while the vertical velocity changes linearly according to Newton's law. These combined effects result in a parabolic trajectory. You probably recall from secondary school the root formula to find the zeros or intersections point with the horizontal axis of a parabola. It is x1 equals minus b minus the square root of b squared minus 4ac divided by 2a. And the second root is the same, but now with a plus sign before the square root. If we use the root formula to solve for the zeros of the cannonball trajectory we just saw, then we can find out exactly where the bullet will hit the ground. Also, we could find the maximum height of the cannonball easily by just calculating the y value at the point x equals minus b divided by 2a.